All right, so we've got this polar equation. Um, it's in the form to be a conic section. The thing I noticed is that there's already a 1 right there, so that this number right here is the eccentricity. Okay. The other thing from the formula that they give us is that 8 on the top is E times D, and there's a 1 right here. So E is 2, so this is 2 times D. It tells me that the directrix is a distance 4 away. D equals 8 divided by 2. Sorry, that should be an arrow. Arrow. 8, D equals 8 divided by 2, which is 4. Okay. So I know that the directrix is 4 away from the um, origin. So anyway, I don't rely on the formula so much is that I rely on looking at what the denominator is doing, because the denominator is really the one that is driving things here. So if I look at, say, the graph of y equals 1 plus 2 cosine theta, here's y, here's theta. Okay, that's an amplitude 2 cosine curve shifted up 1. So shifted up 1, amplitude 2, it actually goes positive and negative. Cosine curve generally starts up 1, but since it's amplitude 2, it starts up 2, shifted up 1 anyway. So from that shifted up thing, I'm up 2, and then I go down 2, well, I go down to here, down 2, back to there, up 2, back to here, down 2. The thing is, between 0 and 2 pi, I go up as high as 3, I go down as low as negative 1, right? That would be at pi right here. This point right here is pi over 2, and this is 3 pi over 2. Now, this is my denominator, but what it tells me is that there's two places right here, a little bit bigger than pi over 2 and a little bit less than 3 pi over 2, where that denominator will actually equal 0. In fact, I can figure out when, because I've got 1 plus 2 cosine theta equals 0. So cosine theta is minus a half. And when is the cosine equal to minus a half? Cosine would be negative 1. There's two places, negative 1 over 2, negative 1 over 2. So a third quadrant angle looks like 2 pi over 3 and 4 pi over 3. So in the second quadrant, at 2 pi over 3, and in the third quadrant at 4 pi over 3, there's going to be zeros. The denominator is going to be 0, which means that I have 8 divided by 0, which is going to be really big, so that when I draw my final result in the direction of 2 pi over 3 and in the direction of 4 pi over 3, I'm going to have vertical asymptotes. Not vertical, but asymptotes. This is going to be a hyperbola, because there's two places where this denominator goes to 0 and hence r goes to infinity. Okay, so now I'm just going to plot some points here. This is my x-axis and my y-axis. I noticed that at 0, that's when the denominator here is as big as possible. It's a 3, so I've got 8 divided by 3 in that direction. So 8 divided by 3 is 2 2/3 or something like that, right? 8 divided by 3, that's that point right there. By the time I get up to pi over 2, so I'm looking in this direction, this is down to 1. 1 divided by 3, wait a minute, what is it? This is up to 1. 8 divided by 1, there we go, 8 divided by 1 is 8. And so in that direction, I'm clear out here at 8. It's way out, so it's gone from here and climbed up to there. The denominator has gotten smaller, which means the whole fraction has gotten bigger. So we've had this short thing getting longer and longer and longer as you go out, and this is going to be heading out towards that direction. By the time you're looking in the direction of 2 pi over 3, looking that way, you're out at infinity. Okay. Then you're going to come on the other side. This is negative, going all the way down. So when you get that way, the denominator is negative. You got 8 divided by a negative. You're going to be plotting a negative number. It's going to be coming back in from here. Right? You're looking in this direction, plotting behind you. So you're going to be plotting back here. At pi, so by the time you're looking in that direction, why is this not being a pencil? Let's grab a pencil again. Good. So by the time you're looking in this direction, this is down at -1. So I'm looking this way, but it's at -1. That's the denominator. 8 divided by -1 is -8. So I'm looking this way, but I'm way back here at -8 somewhere. So it's going up like this. Then this denominator starts getting closer to 0 again. So this thing starts headed off towards infinity. And it's going to be parallel to that asymptote as we go out that way. Then you get to the other side, it's going to come back in here, go up there. So what do I see? I see a vertex right here at 8/3, 0. I see a vertex right here at 8, 0. It looks like a -8. That's because I was looking this way. So in the direction of pi, I went -8, which actually puts it at a +8 on the x-axis. So there's my 2 vertices. The point right smack dab in the middle of them would be the center, right? So if I add those up and divide by 2, so 8/3 plus 8 divided by 2, what's that? 24, 32/3 divided by 2, so times a half. So that would be 16/3. So the middle point there is 16 divided by 3, 0. What else am I supposed to find here? Show the conic sections hyperbola, find the vertices and the directrix, and indicate them on the graph. Find the center of the hyperbola, sketch the asymptotes. Anyway, yeah. So once you have the center, the asymptotes are parallel to those ones we said, but they pass through the center. So there's the asymptotes going like that. The directrix would be out here at 4 somewhere. This is 8/3, so that's like 2 2/3. 16/3 is bigger than 4. So the directrix is out here somewhere. It hits the axis there, the x-axis at 4. They didn't ask for the foci, but I can tell you where the foci are as well, because I know in any conic section that's set up this way, with this polar type equation, one of the foci is at the origin. And then the other focus is the same distance away from the other vertex. So once I know where the vertices are, and those came from, the denominator being as big as possible and the denominator being as little as possible there to get these 2 points, then this 8/3 distance over here, I got to do the same thing 8/3 over there. So this distance right there, so this is 8 plus 8/3. What's 8 plus 8/3? So 24, 32/3. Right? Oh, look at that. It's actually double 16/3. Of course it is, because it'd be halfway to the middle and then halfway out to the other focus. Okay. Anyway, there's that one. If there's still more you want to know about it, just ask again and I'll explain more that I can. I really do focus on that denominator. See when it's as big as possible, see when it's 0, those are giving me the asymptotes, and then see when it's as small as possible, that's giving me the other vertex. So the 2 vertices come from those, and the asymptotes come from where you cross 0. Anyway, there you go.